So cement is the glue in concrete, and concrete's the second most consumed thing on Earth behind water. It's about 30 billion tons a year, and it's roughly 8% of the world's CO2 emissions. And so the challenge with concrete is just not only is it high in CO2, but it's just such a massive industry, massive problem to solve. And it's hard to get people to fathom how big this is.
So welcome to this week's Leaders on a Mission. I'm your host, Simon Leich, and I'm really thrilled today to be joined by Ryan Gilliam, CEO of Fortera. Now, Fortera is really revolutionizing the cement industry with groundbreaking solutions that tackle one of the world's largest sources of carbon emissions. Now, with over 20 years experience in climate tech, Ryan has witnessed the highs and lows of this kind of tough tech, challenging yet vital field. And, can't wait, Ryan, to get stuck in to your journey and really what it takes to innovate and lead in an industry critical to solving climate challenges. And I've managed to pin you down and get you on the show today. So look, really appreciate your time. Thanks for coming on.
No, I mean, obviously, thanks for the invite. I've been looking forward to this.
Awesome. So, Ryan, with 20 years working in climate tech, right? I'm curious, where did it all start? I'm thinking, what inspires you? Like, not so much even at the beginning, but like now, 20 years on, you're an inspired guy, right? So what continues to fuel your commitment to solving some of these challenges today?
I would say I think it's changed over time. When I started into climate tech, I was doing my PhD in hydrogen green fuel, space. And so obviously I was already thought there was a need to solve for that, was in that space. It coincided really well with An Inconvenient Truth coming out, which I think for a lot of us in climate tech, we look at as, Al Gore's movie really helped kind of inspire us in terms of why this needed to happen. So early on, it was really purely a mission-driven thing. I thought, if I'm going to dedicate this much time to work, I want to do something for the better that I think can help the world. I think over time, what I've, as I've been in the space and as I've seen really cool technologies come and go, as I've been part of really cool technologies, I've gotten to a much more hardened thesis that there is real things we can do in climate tech that are good for the world, that are actually economic and can scale and can help solve this problem. And so I think getting to that thesis where I know there are things that can really help, they're just, it takes time and you have to persevere to get through all that. I think knowing that we can actually make a meaningful impact and have something that, can impact the world for the better going forward, that's what keeps me going. And honestly, I think the other thing that everyone would probably say that's stayed in space a long time, it really does come down to team. You spend so much time at work. When you get an opportunity to work with just great people that are mission driven, it can keep you inspired to come in day to day. And I've luckily been able to work with people across multiple companies now that, are mission driven and just great people to work with.
Yeah, no, great. And look, you've been working, I'm right in thinking, you've been CEO before as well, right? So it was a Calera corporation. I know you worked there for 11 years. So, you've done the CEO role before. And I'm right in thinking you really work with this particular kind of technology or the application of it as it relates to cement for a pretty long time, right? Tell us about that.
Yeah, so just in terms of companies, I've founded multiple companies in climate tech. I've worked in green chemicals, I've worked in green energy, and I've worked in cement. But Fortera itself, the way I describe it is we're a 4-year-old company, but we're 17 years in the making. After finishing up grad school, I moved to California to join a company called Calera. It was really the first CO2 to products company and incredibly successful technically. We created a new type of cement that was 44% by weight captured CO2 that could be used both as a partial cement replacement or as a standalone cement. And so it was an incredibly successful company technically. The problem with it was really just, frankly, wasn't grounded in economics. During Climate Tech 1.0, people thought people would pay for green, people would pay for CO2, and that's what would drive adoption. And so I did take over CEO of that company. I pivoted into the chemical sector and shut down that CO2 to cement business back in about 2014, 2015, with the viewpoint that, if we could figure out how to do that differently or make the economics work, we'd revisit it. And so fast forward to 2019, and I would really say it's 2020. We opened up the first labs for Fortera the week before COVID hit the world. So great timing to start a company. But what we really figured out was we could take that technology that we had already put 100,000 hours of R&D into, we had over 100 patents on, we had piloted it for multiple years, we put 100 tons of it in real world applications, we did sidewalks, we did office buildings. But we finally figured out we could take that technology, but instead of competing with the cement world, and this is part of our thesis, but if we actually work with the cement world and leverage what they do incredibly well, which is feedstocks and infrastructure and really driving down capital costs and operating costs, we could take that technology we had proven out, but now do it in a way that's actually economically competitive and works within the existing cement ecosystem with existing cement players as opposed to competing with them.
Got it. Okay. No, love it. So tell us a little bit then around, I suppose around the problem that you're solving.
Yeah. So cement is the glue in concrete, and concrete's the second most consumed thing on Earth behind water. It's about 30 billion tons a year, and it's roughly 8% of the world's CO2 emissions. And so the challenge with concrete is just, not only is it high in CO2, but it's just such a massive industry, massive problem to solve. And it's hard to get people to fathom how big this is. An example I'll give is, if you think of copper metal, I mean, copper is used to electrify everything we do. It's 22 million tons a year, I think is the market size. So you have more than 1,000 tons of concrete for every ton of copper out there being used. And so it's a huge problem. It's effectively used to build our civilizations, but it's also a big CO2 challenge. And so what we're really focused on is paving the way to zero CO2 cement. And again, the cement is the glue in concrete, but 90% of the CO2 emissions of concrete tie back to that making of the cement.
Okay. So 8% of global CO2 emissions. So that's kind of, roughly speaking, that's about 4 billion tons or 5 billion tons. Wow. Okay. That's huge. I never actually realized it was that big an issue, to be honest.
Yeah, and that's one of the parts I think people get wrong too is, we regularly hear, well, why don't we just replace cement and concrete with another building material? And so, yes, it's 8% of the world's CO2 emissions, but it's actually one of the lowest CO2 building materials. It's just so intensive because of how much of it's actually used. So I think what that really says, to me and why we're driven, to focus on this is that cement, concrete aren't going anywhere. That's effectively what creates civilization. And it is a low CO2 per ton, building material product, which means we need to figure out how do we actually reduce the CO2 per ton as opposed to really having the ability to replace it.
Got it. Yeah. So tell me then, how do you do that? How do you make a material which reduces the amount of CO2, within it, as it were?
Yeah, so I'll try and do this as simple technically as possible. But traditional cement, the main feedstock to the kiln is limestone, and limestone is calcium carbonate, which is 44% by weight CO2. Actually in that mineral, right? So solidified carbon dioxide. And when you put that into a kiln and heat it up, you lose that 44% of its weight to CO2 emissions, which is why making cement is so CO2 intensive. So in our process, we take our cues from nature. And so if you look at how coral reefs and shells form in nature, you actually absorb CO2 in the ocean and make a reactive form of limestone that's actually cementitious. And so what we figured out industrially was how to take what nature does that only happens in a fraction of a second and scale it up to an industrial process where we can make this reactive calcium carbonate, so it's 44% by weight captured CO2, and put it in a cement silo or in a cement bag and only have it react then when we add water back to it. And so I always say this a little bit comically, we're basically taking limestone and turning it into limestone, but we're going from an inert rock to another form of limestone. It's these little ball structures called vaterite, in the technical side of it, but it's this reactive form of limestone that can be used both as a partial cement replacement in traditional cement or as a standalone cement. Okay,
that sounds pretty neat. And how challenging is that process? How complex is it? Look, I went on your website. I did have a look. It explains it exceptionally well on your website, but and it does look quite complex.
So I think this is the interesting thing about developing tech. In my early years of developing tech, the more complex it was, frankly, the cooler, sexier it was, the better chance you had at getting investment into developing it. I think one of the thesis changes that we had to go through, though, was if you don't simplify the technology so that it's low cost materials of construction, it's proven process units that are scalable, that have already gone through kind of that cost curve reduction to get to cheaper costs, it's really hard to scale the technology, especially at the scale that we need to get to. So the process itself was many years in the making to figure out how to make the chemistry work. We're trying to make a form of limestone that's actually reactive, that in nature only exists for a fraction of a second. So it took us many, many years to actually figure out how do we, absorb CO2 and precipitate and make this reactive form of limestone, again, that we can put into a cement silo or a cement bag. So that took us many, many years. But from a process perspective, I'd say the last number of years have now been focused on how do we simplify that chemistry so that we can get to scalable process units that are effectively off the shelf. And I think if you look at our website and look at the process, what you'll see is after we precipitate or make our material, really all the other process units that are there for drying and separating that material out are all very standard from the wastewater industry. In our case, the waste is actually our product, the good piece, but it's all very standard equipment. And that's, again, by design, because it's really the only way you can get to scale and reduce costs.
Yeah, got it. And also, I didn't actually realize, but obviously making the technical standards of what cement is as well. Clearly, it's a very durable material that so much of it is used for a specific reason. So how much of a challenge is actually making that particular kind of requirement, as it were?
I mean, cement and concrete are used in very, in life-bearing applications. You're putting into bridges and buildings. And so, it's a risk-averse industry, but for good reason because of that. So yes, the regulatory process is a challenging process. We have the benefit. So our blended material, we've worked with ASTM in the US to propose language to get those regulations changed to specifically include manufactured calcium carbonates like what we make. And so we were successful in that. The regulations, I think it was last August, updated specifically to allow materials like us in the regulations. But just to put that in perspective, that was more than a 2-year process. And there's upwards of 160 voting members from the cement and concrete world. So it really is about getting them data, getting them to understand the material, getting to see why it works so that they'll get comfortable with it. So that's where we started, and we fit under the regulations. The longer term goal, I'm sure we'll get into this more detail, is to go to higher and higher percent replacement with our material, all the way to 100% our material. And there are performance-based regulations out there that we can fit under, but while there are performance-based regulations, the market as a whole doesn't generally specify to performance-based. They're more compositional-based regulations that people specify to. So getting people comfortable will mean getting the market to shift a bit, but also getting the regulatory bodies to get more comfortable with our material as well.
Okay, I had no idea it was so stringent, and there was such a process to go through. So where have you got to then in terms of the scale? Because I know you have a demo scale facility, right? So just kind of run through what that looks like and where that is.
Yeah, and we define it really as our small commercial facility. I think everyone has different definitions of pilot, demo, and everything else. Generally speaking, my fundamental definition difference is when you go from demo to a small commercial, logistics actually become a challenge. I mean, so our plant in Northern California, Redding, California, is 15,000 tons a year of our material. Which, when you put it in a 10-15% blend in concrete, which is where with cement in concrete, which is where we'll start, it's about 500,000 tons of concrete. So small in the grand scheme of the concrete world, but not a small amount of material from an overall market perspective. And so that plant came up online. We did the ribbon cutting earlier this year. really the beauty of getting to first of a kind plants is really getting past that proof point on, does the chemistry scale, does the process unit scale, can we meet the capital and operating cost targets and validate that relative to the plant. So the hardest part, I think, of any new tech, especially in climate tech, is getting to this first of a kind type facility, which is what we now achieved. And that's really what then unlocks this ability for commercial rollout.
Got it. Okay. So really starting on the journey of the valley of death, as it were, right?
Yeah. And everyone talks about first of a kind really being the valley of death. I think there's really multiple different valleys of death in tech startup. Most technologies, and I've been part of a number of different tech developments that have this challenge, but most technology, I think that first valley of death is getting to the first of a kind plant, which we were able to achieve earlier this year. And that really comes down to the fact that when you're developing a new technology, you need to go through this pilot and demo phase, which we had the benefit of we had done in that original company. We had a demo facility that was 2 tons a day of product, and that we ran for multiple years. But each of those types of endeavors are typically upwards of 3-year type endeavors. By the time you design, do the detailed engineering, procurement, construction, commissioning, running those plants, these are long time windows for each of these stages. And that's where I think the challenge comes in. If you're going to take 3 years to get through piloting and another 3 years to get through demo, and then you need to raise considerable money to get through first of a kind type funding and then build your first of a kind plant, that's why it's such a long timeline development window to get there. And so that to me is really that first of a kind is that valley of death. The next valley of death is when you go from first of a kind to commercial rollout. The fundamental challenge you have is you're still going through some scaling, which means there's still some risk there. You're still early in terms of kind of a bankability perspective of traditional project lenders, debt, and project financiers coming into a project. And so we're in that, I'd say, the second big valley of death, which is really securing the funding and securing the partnerships to roll out the commercial operations.
Yeah, no, got it. And so tell us a little bit about that, because I saw you announce, like, not so long ago, quite a significant kind of C round of investment. I think it was about $85 million investment. And, is that essentially to provide the capex, as it were, to build this commercial scale facility?
So the plant that we built in Northern California, some of that was towards the capex. We did self-fund the first of a kind, and I think that's one of the challenges is how do you get investment in for a first of a kind? Because at first of a kind, you're typically not at a scale where you're going to pay back your operations, you're going to be making money, you're going to be paying back that capital. And so you do need to figure out how you're going to fund those. So that some of that Series C went to funding that first of a kind plant, but it really is also for funding to set ourselves up to now go after commercial plants. And there's a leap between first of a kind and commercial where, any project we do know has pretty significant development dollars you need to be putting in, from permitting to your engineering feed packages. And then we also will need to bring some equity to the table to get investors comfortable at commercial projects. So that's really, we're setting ourselves up now for a pipeline of commercial projects and making sure we can bring in the development dollars and funding to do those.
Got it. Okay, awesome. So it's a really significant kind of hurdle where you've got to now, and at this point. But as you say, I've never thought about this before, but multiple valleys of deaths almost, right? So
yeah. And I think a lot of companies never really get to this full commercial rollout phase. At least in the climate tech space, there hasn't been a significant number that have got here. So it's a valley of death that I don't think is completely appreciated. And it really, again, ties back to the fact that there is this lack of funding available in the market for these first plants where there is still some risk, and you're kind of not at the stage where you can go get more traditional debt and project finance.
Yeah, no, got it. And just a couple of things come to mind, like just unpacking some of this stuff. It's really interesting. Like this facility coming online in Reading, which was a major initiative for a relatively kind of small company, to build out. What were the major challenges you had to kind of get through for that one?
How long do we have?
Or is that a separate show?
Yeah, that could be multiple shows in itself. Look, anytime you do a project like this, again, as a startup company, you're probably always at a point where you're understaffed to really take on a big project. I mean, this project, as I said, is 15,000 tons per year, covers an acre of land. We have, there's buildings on it that are 8.5 stories tall, kind of silos. Like it's hard to, you'd have to almost look at the pictures to get context of the size of this facility. But so when you go through that, I mean, every step of the way is a big learning curve, and you're trying to staff up to meet those challenges, those risks as you go. I think, yes, everything from getting through the permitting process, and which was not an easy endeavor, and we learned kind of the hard way on a number of things there. Getting through working with an engineering procurement construction company to get that design done, get it to our specs, and get it to a timeline and budget that works is no small feat. So I will say that what I'm lucky to have, and this is really gets my thesis of startups together, is you have to have a team that can stay optimistic and that can persevere, because there's never a day where you're not going to encounter a challenge when you're trying to do something for the first time. And I think the benefit that we had is that, yes, we hit a lot of hurdles along the way. And again, that we could do shows on that alone. But even, with all those hurdles that came up, the team was able to rally around each of those to figure out, okay, what are our options? How do we solve it? How do we keep moving the ball forward?
Probably makes you stronger as a team. But clearly a lot of risk online here. It's not just like make a decision. I speak to a lot of people that say, you know what, make a decision, see if it works. If it doesn't work, we change course. Doesn't seem that is that apparent in this case.
I think you're always fighting two things. I mean, there is analysis paralysis where people are going to be hard to make decisions. So there is a point where you have to gut check and say, yes, you'll make a decision, go. And I've made a lot of mistakes and cost, a lot of capital over the years by making those mistakes. But the other thing you're always fighting as a startup is time matters, right? And the longer it takes to get to something, your burn rate as a company, you're going to have to keep getting more funding to do it. So you're always weighing off the decision and the impacts it could have versus how much time are you going to wait before you do enough analysis, do enough data, search for making those decisions. And I think when you have a good team and you can sit and debate those out and come to a conclusion and make a decision and go, whether you're right or wrong, if you have the team rallied around those decisions, you can keep moving stuff forward.
Yeah, okay, great. And the other part I was going to mention about that was, now, at what point are you able to kind of sell offtake? Or when it comes to considering building and finding finance for it, does this depend on kind of really bankable offtake agreements with customers?
I would say that is probably, you're touching on probably the hardest part of why I say there's a second valley of death here. We are bringing a new product to market. Yes, it fits under the regulations, but it's still a new product to market. And what I would say as a whole on the cement space, and really you'll find this for a lot of these like high capex, low margin, very large commodity spaces, is they don't necessarily work off of offtakes. That's not typical in the cement world.
Right. Okay.
And typically, yes, they have the ready mix or the concrete people they're selling their cement into, but it's not typically done off of firm offtakes or take or pay agreements. And so you have that on one side, and then the project finance world and the debt world really work off of firm offtakes for bankability to get comfortable in projects. And so once we've gone through, multiple commercial projects and we put hundreds of thousands of tons of material to the market, I think we'll be able to get those two different views to converge and get comfortable with the risk and be able to put the product to market. But where we're at right now is we have, more traditional project finance side that wants take or pay offtakes. We have cement world that doesn't typically work off of that. And so figuring out how to make deal structures that gets everybody comfortable with, a level of risk that they're willing to take on to be able to fund these projects is, to me, I think the big challenge that I don't know if it's really been solved for new techs out there. And I don't know, we've done things where I think we've been creative on business development. We've been good at building credibility and going down the risk curve with our partners. So I feel like we're a long way down this road already. But this is what we sweat every day at this point. We have a considerable number of commercial projects now under MOU or in definitive agreements for a considerable number of commercial projects, and making sure we can actually bring the funding to the table to do them is now the big league.
That's the question. Okay, no, great. I'll come back to that bit in a sec. I suppose I wanted to touch upon that fundamental shift in business model you spoke about. From Fortera to Fortera, as it were, which was really involving the cement manufacturers as your partners, as it were, as opposed to my sense was you were going to compete with them almost beforehand. So now it's much more collaboration orientated. So maybe just outline about what that collaboration looks like and where it sits.
Yeah, so there's really kind of two key things that I'd say changed between them, and they're all obvious now in retrospect. But in the Clara days, we were looking to be a carbon sequestration company. So we would partner with the coal plants of the world or others and capture their CO2 to make our reactive carbonates. In doing it, to make a reactive carbonate, you need three things. You need CO2, you need calcium, and you need a form of alkalinity. And so in the Clara days, we were looking at a whole range of different sources for calcium, a whole range of different sources for alkalinity. We were partnering with CO2 emitters, and we were making this carbon negative product. What's different in the Fortera days is what we looked at and said, we don't necessarily need to be carbon negative to be a really positive impact from an environmental standpoint. And so if we need calcium, alkalinity, and CO2, we can also get that directly from the cement or lime companies, because they're taking limestone, they're putting it into a kiln, they're making calcium oxide and CO2, which calcium is we need, the oxide is the alkalinity which we need, and the CO2 is being emitted, which we need. So it really is more of from an overall thesis perspective, being okay with we're going to be a much lower CO2 or even all the way to a zero CO2, but not necessarily carbon negative. It's being willing to accept that's really what we're trying to solve for. And then by making that decision to do that, what it opens up for us is now we're able to, from the cement company perspective, they're already located at limestone quarries. That's 80% of the feedstock in traditional cement plant. So the only feedstock we need is the limestone, because that gives us our CO2, our calcium, and our alkalinity. So we're able to use the same feedstocks they already have at their plants. The infrastructure, the $1 trillion worth of capital infrastructure from quarry all the way through to kiln, we're able to now leverage all of that so that we can get to that same starting feedstock. We're able to leverage all their back-end logistics and sales, so we can put it in as a blend or as a pure product, but through their distribution channels, a lot of times they're vertically integrated with ready mix, the concrete people, so they can put it out to market. And it really is by leveraging all of that, that's what helps drive our costs down to be competitive. And the hard part of new technologies, and I worked on the venture side for a while as well, looked at many companies, especially in the climate tech over the years. There's a lot of technologies that look okay or look like they could be economically competitive on a greenfield versus greenfield perspective. So if we're going to build a brand new cement plant, or you're going to go build this green cement plant, they could compete. The hard part is that's not typically the reality, right? These cement plants already exist. The capital's already been paid. So you're trying to bring a technology to market where you're really just competing with someone that only has operating costs, now. And so if you don't leverage their infrastructure, if you don't leverage their, everything that they've put in place, it makes it a lot harder to build a project that can be economically competitive if you're really competing with the industry as it exists, as opposed to a paper study on a greenfield versus greenfield perspective.
Fascinating. Yeah, I suppose that comes down to the pure nature of that business and the commodity, huge volume approach of it, right? And the huge volume output. And what is their attitude? What is the customers and their customers' attitude towards decarbonization in this way?
This is one where I think a lot of people get this wrong. What I have found is and this is different from Climate Tech 1.0 to now, but I think at this point now, all the major corporates that we talk to are interested in solving, whether it's climate sustainability or however you want to package it, but to reduce those CO2 emissions. And so we've had no shortage of cement companies and ready mix companies willing to test our material and try it out. I think what people get wrong is the reason why it hasn't been adopted broadly is people have not put economically competitive solutions, on the table. And to expect a big cement major to adopt technology that's going to require a green premium or erode their margin, it's going to be very difficult for them to stay competitive in a space when not everybody's going to necessarily be mandated or do it. So what we found was what resonated is by actually leveraging, again, their infrastructure, their feedstocks, their logistics, really they can bolt our technology on beside their plant, increase capacity, reduce CO2, put a product out to market, and still make margin. That's why I think it's resonated so well, is that they see it really as an economic proposition that has the benefit that it's also sustainable.
And you mentioned before about the various mixes, you blend them. Is there, when you think about your pipeline or the future, I think you've also spoken about them going directly, that being used directly as a pure kind of cement as well, right? Is that how you see the development of the product, as it were?
It's been interesting. I think, when you try and get people interested in working with your product, we have one of our core values of the company is think customer. And so from early on, it's always been about really trying to understand from the customer perspective, what do we actually need to solve for, or what does our product need to do? And so when we talk cement, that's a pretty general term. Cement's actually fairly different site to site. There's a lot of different ways people blend cement into concrete to get to different types of performance properties. So a lot of the way we've looked at our product and our tech development is really being smart on the engineering of how to tailor our product to meet specific market needs or customer needs. So I think early on what you're going to see is we will do a lot of these different blends, and it won't just be blends with cement. It'll be blends with other things in the market like fly ash and slag and things that are already being utilized to help on sustainability. And what we've shown is we can add our material in and help with specific properties like early strength or flow or some of the other things that these contractors and end users really will care about. So that'll be really the focus early on. The holy grail for us always has been going to 100% our product. If you do 100% our product as the cement, and especially if you then integrate with green fuels or green energy, it is a zero CO2 emission cement. And we know that that'll take some time for people to get comfortable with it and adopt it and for regulations to move. And so now what we're focusing on from our Reading plant is putting some of that first 100% product out there in specific applications where people will feel comfortable bringing it to market. Again, with that longer term holy grail being doing the 100% product, as what we roll out broadly. And again, the benefit to the cement manufacturers is, a lot of times you could view this as competitive, but because it's still their feedstocks, their infrastructure, they're putting it to market, we're really giving them a pathway where they can get all the way to a zero CO2 cement and still be the ones putting it to market and making margin on doing so.
Got it. Yeah. And you can concentrate all your resources on that side as opposed to the customer, as opposed to distribution, as opposed to, like becoming that type of organization, as it were.
Yeah, and I think that down the road, that would really be the goal, is that they would be the ones putting it all to market and doing that marketing side piece of it, which obviously is a big endeavor in itself. Obviously, early on, we also want to create that market pull. So we do work with the end users and architects to get them comfortable with our material. But that's all from the view of the more people see it, the more people get comfortable with it. They see the advantages of it and what things we can solve for with it. The better chance we have of really pulling the market in that direction. Makes
a lot of sense. There's probably an educational component to it as well, isn't there? I would have thought with that as well.
Yeah, absolutely. And what we've kind of gotten to as a company is when we talk about the type of product we make, I think there's a healthy skepticism always about what are you really proposing? How does 100% really work? And so we always push to get people and potential partners onto our site, because if you come to our site, you see the labs, you see how the material's working. We'll do a demonstration where we'll actually do the 100% product with you, and by the time the meeting's done, you'll see it'll set up, as a cement would. That's really where we get people comfortable then with what we're doing.
Yeah, no, got it. Great. So where would you dreams and hopes now, looking ahead, right? In terms of this next juncture, what's really feasible for you and the company over the next kind of 5 or 10 years in this space?
Yeah, look, we kind of started this at the beginning of the talk, but I'm in climate tech, so I actually want to have a meaningful impact in the space. It's not about getting to 1-2 commercial sites. When you're talking a 30 billion ton a year market, unless we build a considerable number of cement plants, we're not really going to meaningfully impact the CO2 emissions. So our focus really is building out the business model, building out the ability to finance these so that we can roll out plants as broadly as possible. We're already, we're working on our first commercial plants in the US, but we have, projects that we're looking to now in Canada, into Europe, into Southeast Asia, and then even more broadly than that. And so what I would like to see over the coming 5 years is that we'll have a number of these commercial plants both running and then in progress being built out. And just being realistic, these commercial projects are 3-year type endeavors, and so we're in that process now with some. But by the time you go from, again, permitting through engineering, through long lead procurement, construction, commissioning, these are long windows. So before 5 years is up, I would like to see a number of these already up and operational, not just in the US, but more broadly. And then from there, it really is then being able to show that we've hit a cost curve, we've hit an ability from a risk perspective that we can broadly project finance these and build these out.
I've got it. So all of these are going to be built on sites, are they, of cement kind of manufacturers, essentially?
Yeah, I mean, we firmly believe that the way to make the economics work is to, again, leverage what they do well. And so we all of the sites that we're contemplating at this point are all co-located at our cement or lime facility where they have a kiln, they have the limestone available.
Yeah, no, great. I mean, that gives me some great context. In terms of impact, what kind of impact could you see? Like, if you think about, I don't know what size a full demo scale facility will produce, and therefore what CO2 will you kind of save, as it were. But do you measure kind of impact as simply as that, as it were, just from that rudimentary?
That's probably the fair way to look at it. So our plants, if we continue to use the hydrocarbon fuels at the kiln, we're about 70% lower CO2 per ton of our product versus traditional cement. The first commercial plants we're working on right now are all nominally about 400,000 tons per year, each plant. And so if you think about a 400,000 ton per year plant, we'll be directly capturing more than 160,000 tons of CO2. And then with offsets as well, you're getting into the mid 200,000 tons a year of CO2 for each plant we'll be doing.
Got it. Okay, so mid 200,000. Okay, that's awesome. And is there a revenue stream here with carbon? Where does it all fit with the carbon credits story and business model, and how does all that sit together?
Yeah, I think just like if you think of wind, solar, electric vehicles, when you're early into the technology development, the first plants cost more, they're less efficient. You haven't gone down that cost curve yet. And so really we're looking to CO2 incentives, whether it be 45Q tax provisions versus CO2 offsets on the voluntary offset market. We're really looking to those as giving extra economic incentive to get partners early to adopt. The long-term goal would be to not be reliant on those and to be cost competitive selling cement at traditional cement pricing. And we fundamentally believe our technology does that, but we are definitely utilizing those incentives early on to help get through this early stage where you are higher price on plants. You're not at what they call nth plant pricing yet.
Awesome. No, great. And that sounds like you're going to be very busy over the next few years.
I don't know if we've ever not been busy, but yes, the hope would be that we would be busy. I think, a lot of people are looking at climate tech now, wondering exactly how everything will unfold over the coming years. I think, again, if you stick to this thesis of having technologies that aren't necessarily reliant on green premiums, aren't necessarily reliant on government incentives, are truly economic propositions that fit, again, products under the existing regulations. I'd like to believe that, what we're seeing from the industry is that people will be, want to adopt the technology. So yes, it should be a very busy coming few years.
Awesome. Well, listen, I could chat all day with you about this. It's been really interesting, Ryan. So just wanted to say thanks so much for coming on and sharing your great insights and kind of journey over the last 20 years or so. And, the journey you're on for this one, this first of a kind of technology to really transform, such a high CO2 emitting industry, right? So thanks so much for coming on and sharing the journey.
Absolutely. Thanks so much. Great
And
conversation.
and look, to all our listeners, I hope Ryan's story leaves you kind of motivated to think big and act boldly in your mission. So until next time, stay curious and keep leading with purpose. Thanks for tuning in, and see you next time.